If you've ever read Flat Stanley, then you've wondered, can you actually turn things totally flat? Okay, maybe not with a falling bulletin board, but turns out you actually can make things just one atom thick, with tape. By taking graphite, a material already made of many atom-thick layers, and using tape to peel one off, you can create 2D graphite layers, aka graphene. Nowadays, there are much better ways of doing it, but the principle remains the same. Now hold on, what makes 2D materials so special? In most materials, electrons move like balls rolling across hills. Graphene flattens those hills into a perfect ramp. With no bumps, electrons just zoom straight, almost like the photons in beams of light. This is why graphene's electrons are called effectively massless. These massless electrons respond almost instantly when you turn them on or off, almost like lasers. That's why graphene transistors are hundreds of times faster than silicon ones, making technology way more efficient. It's also nearly invisible. In atoms, electrons take in and reflect back light. So when you have a 3D material with lots of electrons, the material blocks a lot of the light. But in a 2D material, there are so few electrons the light barely notices. In fact, each layer blocks just 2.3% of visible light. Dreams like invisible solar panels and touchscreens get way closer. And even though it's thin, it's crazy strong. In a 3D material, when we put force on one atom, many atoms hide in the middle and don't carry much load. This makes 3D materials pretty weak. But in 2D, every atom is part of the surface network. When you tug on one spot, the whole sheet carries the load. Fun fact, if you made a hammock out of graphene, you could balance an entire cat on it. So the magic of 2D isn't just that it's thin. It's that the discovery of 2D matter means massless electrons, nearly invisible sheets, and super strength material. A breakthrough that could reshape the future.